welcome to my YouTube channel. Today we have to prove this, that the integral from 0 to pi of this x all over 1 plus sine of s dx is equal to pi. So we need to take note of these identities here. So this is the integral representation of the beta function, and this is the relationship between the beta function and the gamma function. So these are going to really help us here. So let's get started. Now, denoting this integral with our integral from 0 to pi of x all over 1 plus sine of x dx. So let's take this substitution, and this is just this King's rule. So we can say let x equal to pi minus y. Actually, y is the same as pi minus x, then dx from here is equal to minus dy. So we have I is equal to, now the limit, so when s is equal to 0, y is pi minus 0, that is pi. When x is equal to pi, y is pi minus pi, which is 0. But because of this negative sign, we are cancelling it out. So this limit is going to switch to 0 to pi. Then we have, the value of x here is pi minus y, okay, over 1 plus sine of pi minus y is sine of y, then dy. So we're going to split the denominator, so we have integral from 0 to pi all over 1 plus sine. We can change the variables here since this y starts as dummy variable here. So the x, then minus integral from 0 to pi, then x all over 1 plus sine of s ds. So now remember that this, our I here is this here, so this is I. Now we're going to add this, that is I plus I is equal to this integration here. Then so we have I plus I, which is 2I, is equal to this integration here, integral from 0 to pi all over 1 plus sine of x dx. So actually we have I is equal to dividing both sides by 2 here and taking this pi out of this radical here. So we have pi all over 2 integral from 0 to pi, then 1 all over 1 plus sine of s ds. Now we're going to take the Weierstrass substitution here. So saying let x equal to 2 arctan of y. So when we differentiate both sides, we get ds is equal to 2 all over 1 plus y squared dy. So now we have I equal to, remember that this is pi over 2 integral. Now y here is equal to, if you want to find the value of y, divide both sides by 2 here, then y is equal to tan x all over 2. So the tangent of s all over 2. Now s over 2, when s is equal to 0, we get tan of 0, which is 0. Then when s is equal to pi, tan of pi all over 2, which is what? Infinity. Now we have 1 all over 1 plus sine 2 arctan of y. This y we can change it to s. Then the x is equal to 2 all over 1 plus x squared ds. So these two, taking it out, these two and these two cancel out. And remember what we gave here initially, that this identity is equal to this. So if you take the inverse, that is, the reciprocal of this is equal to 1 plus x over 1 plus x, then squared. So this will simplify. Remember this 1 plus x squared over 1 plus x squared, this 1 plus x squared and this gets cancelled. So this will simplify to what? Pi integral from 0 to infinity 1 all over 1 plus x squared ds. So this x here, this one here, I'm going to write this one as x raised to power 1 minus 1 because I want to make use of this beta function here. So we have I is equal to pi integral from 0 to infinity x raised to power 1 minus 1, then over 1 plus x raised to power 1 plus 1, since 2 can be written as 1 plus 1 ds. And this is equal to pi, the beta, remember, so beta of 1, and this is equal to pi, open bracket, the gamma of 1 according to the relationship, the gamma of 1 over, the gamma of 1 plus 1 is 2 here. So I is finally equal to pi, then open bracket, gamma of 1 is 0 factorial times 0 factorial over gamma of 2 here, 1 factorial, which is equal to pi. 0 factorial is 1 times 1 over 2 factorial. 1 factorial is what? 1. So this is equal to pi. And we have proved the question. Then thank you for viewing, and make sure you subscribe to my YouTube channel for more interesting videos.